We are the team engineer people working on the bifold door waterproof shielding project. Bifold doors combine the modern look with the flexibility and reduced space needed to open and close them. The multiple glass panels of the bifold doors provide natural light for an extended length and create a connection between the interior space and the exterior environment. Conneer is one of the companies in the industry with bifold door products. Their products have been the solution to many personal and business applications. The team identifies the problem statement as to design and develop or improve an effective system for bifold doors that provide high performance against water penetration at the threshold and seal area, while keep the original advantages of the bifold door structure. This is the criteria table for this project. The main goal for this project is to prevent water penetration at the threshold area. Well, in this process, the usability in general is the most important thing to address. The testing method used for the water penetration test is called BSEN 12208-2000 Windows and Doors Water Tightness Classification for 750 Pascal. It has a method of using water spray for 5 minutes on each side of the door to check whether there's water leaking into the door threshold. After going through several different ideations, the team chose the final design as using the cylinder cam structure to create a passive lower and lift system for the seal bar. As shown in the graph, all the red parts are designed by the team. There are 3 different positions for the cylinder cam structure. When the door is fully opened, there is a small gap between the gasket and the threshold. When the door is half closed, the gasket starts to get into contact with the threshold. When the door is fully closed, the threshold is pressed into the threshold so that it have a better waterproof performance. For the gasket selection, the team used the Mark 10 device to conduct a deformation test to choose the gasket. Here is the result from the deformation test analysis. These plots demonstrate the proportional relationship between gasket length and stiffness. As the length of the gasket increases, the material experiences a greater area of deformation, resulting in a linear increase in the applied force required to achieve the corresponding deformation. The deformation of the aluminum seal bar is also analyzed. The result gives that the maximum deformation happens at the end with about 1.3 mm, which is acceptable for this application. The stiffness of the follower is also calculated using the shear stress equation. It's calculated to be at least 3.94 megapascal. Compared to the stainless steel, which has 203 megapascal, this material is totally feasible for this application. After the prototype is built, a sealing performance test is conducted by spraying water on both sides of the prototype for 5 minutes each trial and 5 trials per side. The result shows that this structure provides a good waterproof performance. The usability of this prototype is also determined by spinning on the door frame to test the force required for opening and closing the door. The team has determined that the force required for opening the door is about the same as a normal bifold door, which means this structure is acceptable for application.